Okay. In lesson 8.1, of course, we did the product rule where you multiply the bases, you add the exponents, and then here's an example of that. I want you to notice the difference between the product rule and this one, which is the power rule. I use the same exponents here, but notice the difference. When I'm raising a power to a power, I just multiply the exponents, and 2 times 3 is 6. So when I was multiplying the bases, I added the exponents. When I'm raising a base that already has an exponent to another exponent, I multiply the exponents. Now that applies if I have a whole product of things inside the parentheses. Everything is to this fourth power on the outside. So that 2 to the third, by the way, what is 2 to the third? 8, okay, is to the fourth power. Even a number, the base stays the same, and when I'm raising a power to a power, I multiply the exponents. The same thing is true here with the variable. It is already to an exponent. I'm raising a power to a power, and 2 times 4 is 8. Okay. Use your calculator if you have to find 2 to the 12th, or you can use your brain. 2 to the 5th is 32. So double that to get 2 to the 6th. Huh? 2 to the 5th is 32. So double that and get 2 to the 6th is 64. Double that to get 2 to the 7th. 128. Double that to get to 2 to the 8th. 256. Double that to get to 2 to the 9th. Double that to get 2 to the 10th. 1024. Double that to get 2 to the 11th. 2048. Double that to get 2 to 12.
1096.
That's good. Now remember, the book will not write this. They're not going to write that first power there, but you're going to understand that it is there. And then the same rule applies. Keep the base, multiply the exponents. Keep the base, multiply the exponents. What is 2 to the 4th? If 2 to the 5th is 32, 2 to the 4th is 16, right? So 16x to the 8. So everything inside the exponent, or excuse me, everything inside the parentheses gets raised to this outer power. And things that already have an exponent, and everything does have an exponent, right? Even if it's understood to be 1, is multiplied by that outside power and taken to that exponent. All right, questions about the power rule? Here's the thing, none of these rules are difficult by themselves. But then when we take them and put them together, it just causes trouble. So just try to study them and know them separately, and then we'll put them together as a review. All right, let's look at these 3. All right, 2 to the 3rd squared would be, or not 2, 10. 10 to the 3rd squared would be 10 to the 6. Raising a power to a power multiplied. Remember, any power of 10, that exponent just tells you that that's how many zeros that we need. So this number would be 1,000,000. All right, and so this, keep the base the same, multiply the exponents. Keep the base the same, multiply the exponents. Usually I write my number as my coefficient before my variable. That's just a habit we have, right? That's typically what we do. Alright, so if you guys will try those, we'll do them for dollars. So 2 to the what power? Okay. Next. Yeah. Have to squeeze them in, won't you? Y'all get 12 zeros on there? Okay, next. What number is that, guys? A trillion, yeah. Our national debt's past that, isn't it? A good bit past that. Very good. There you go. There it is. All right, questions on any of those? This is hard stuff.
No.
Now all you do is multiply, right? Multiply the exponents. All right, let's look at these three up here. Now pi is a number, right?
Mm-hmm.
All right, so everything up here is squared. So what's this answer? Well, they're to the first power. So I'll just write them like this. See, if I write this, that means y is squared. If I want x to be squared, I have to give it an exponent also. So this is your answer. Alright, this time, this is to the first power. This is already squared, and I have to square it again. So this becomes x to the 1 times 2, y to the 2 times 2. Now, beyond algebra 1, you don't plug in 3.14 anymore, and you don't plug in, 22/7 anymore. You leave things in, the directions will say in terms of pi. That means leave the pi in the answer. And so this will literally be pi to the 4th, r to the 2 times 4, which is 8. Pi was to the first power, multiply it by 4. So I'll just leave it like that. Leave it in terms of pi. Don't try to get a decimal approximation. Leave the answer exact and leave the pi in it. Alright, this is really what we've already been doing. This is the power of a product property, and it just says that inside here they already have exponents, even if they're just understood to be ones, and you just take it to that outside power. That's what we've been doing up here. We've been doing on those previous examples. Alright, so this would be x squared, y to the first, would be x to the 2 times 3, and y to the 1 times 3. A to the first, b is squared, c is to the n power, which is a variable in the exponent, but that's okay. That'll be a to the 1 times 5, b to the 2 times 5, and c to the 5 times the n. It's not hard stuff, is it? So when you have a power and you're raising to a power on the outside, you multiply. And last week when we were multiplying the bases, we added the exponents. And now we're just saying, okay, if I've got a product inside parentheses and I'm raising it to a power, I still just use a power rule. That's all there is to it. Cody.
Why would you put the 5 in front of the n? Would it matter?
Well, do we normally write that or that? I mean, which one just looks better? You know what I'm saying? So yeah, we don't usually write that way. That's the only deal. That's just kind of understood the way it is kind of thing. All right, you guys try these 3 for dollars. That's all you can do. Y'all agree? Can you see them? Unless you use a better pillow. Anybody have questions? It's gonna be an easy test. Y'all keep that in mind. Keep that in mind. All right, let's look at these. All right, so now remember those ones are not going to be there. Just don't forget them. But keep the base the same. Keep the base the same. Multiply the exponents. Keep the base the same. Multiply the exponents. Keep the base the same. Keep the base the same. Multiply the exponents. Now, when we have a number, we can simplify that. What is 2 to the 3rd? Do what? Oh, I saw it too when I looked at that, that's weird. I'm glad y'all called me on that. So this is a 9, alright, thanks, what is 2 to the 3rd? 8. So the final answer, see if I can get this right here. We agree? We good? Alright, I wanted to show you, I'll make that a little neater. Maybe. I want to show you the difference in these. The -1 is part of what's being taken to the 5th power. And when you take a negative to an odd power, 1, 3, 5, 7, 9, it stays negative. You don't have to write the 1, but the negative is there, and 1 times 5 is 5. So you can put the 1 here or not, but the term is still negative. The coefficient is still -1, whether you write it or not. When a negative is on the inside of parentheses taken to an even power, then just like squaring, we know that it becomes positive. If I square it twice or give it to the 4th power, think about -1 times -1 is positive, times -1 is negative again, times another negative will be positive, t to the 4th power. Another thing I need to show you is that there are no parentheses here. So the only thing that's to the 4th power is that t. And you can write it this way or you can write it that way, but that can't simplify any further. That -1 is not part of what's being taken to the 4th power. Alright, let's look at this one. I have a -5 and it's to an odd power, and so my final answer will be a negative. What is 5 to the 3rd?
125.
-125. And x to the 1 times 3 is 3. I don't want to confuse anybody. This becomes that, right? Skip a step there. Alright, you guys try these for dollars. Check. That negative is not part of what's being squared, so just put it up front. It was actually already simplified. That was kind of tricky, but there were no parentheses, and so that's why it just stays the same. Yeah, good. Does anybody have a question? Y'all see that second one? That was kind of tricky, wasn't it? Now, if it had been like this, it would have just been wider than 100. All right, let's look at this one. Now here, we're going to apply the 2 rules that we know. We're going to use our exponents rule, our raising a power to a power rule, and then we're going to use our product rule. All right, so let's take everything in this set of parentheses to the 3rd power, and then we'll take everything in this set of parentheses to the 2nd power. So cube this one. 3 to the 1 times 3 is 3. X to the 2 times 3 is 6. Y to the 3 times 3 is 9. 2 to the 1 times 2 is 2. X to the 3 times 2 is 6, and Y to the 1 times 2 is 2. Now, you'll get to a place where you'll just skip that step and just do this in your, skip on to the next step. What is 3 to the 3rd?
27.
Good. So 27, x to the 6, y to the 9. So like I said again, you'll probably just get to where you'll just skip this step, but I didn't want to do it yet. I don't want to confuse anybody. 2 squared is?
4.
4. All right, now, we finished. We used the power rule. All right, now we're going to use the product rule. All right, so 27 times 4 is the same thing it always has been. What is it? 108. Alright, x to the sixth times x to the sixth. If we're multiplying the bases, what do we do with the exponents? Add them, right. Y to the ninth times y to the squared, keep the base the same, add the exponents. So there's a problem where we use both things that we already know. And that's what the test will be like, where you'll have problems where you'll use different rules to do the problem. But that wasn't too bad either, right? You just have to keep them straight. If you're raising a power to a power, you multiply, and then when you're multiplying the bases, you add the exponents. Alright, you guys try that one. Now, he skipped a step, but 14 squared is 196, right? Hope we know that one. There it is. There it is. Y'all agree? Does anybody have a question? We're gonna ace this test.
Probably.
Alright, so let's talk about volume. We're applying, you were asking earlier about volume, so here's the problem. But it's just dealing with rules of exponents. The volume v of the sphere is given, bless you, by the formula volume is equal to 4/3 pi r cubed. Suppose that the radius r of a sphere is equal to 6s squared, where s is the radius of a smaller sphere. Find the volume of the larger sphere in terms of the radius of the smaller sphere. Alright, look in your books. Open up your books to page. This problem is on page 380. 380. Here's a better view of the formula. It tells us that the radius of the sphere is equal to, and this is, I believe, 6s squared instead of the way that I have it, 6s squared. And so, yeah. So if the radius is 6s squared, and then I've got to cube that radius, that's why this problem is in this particular lesson. Now 4/3 and pi, they're already numbers, okay? What is 6 to the 1 times 3 power? 6 to the third. What is 6 to the third? You asked me a while ago. What's 6 to the third? 216. So 216, s to the 2 times 3 is 6, right? Now 3, let's do some cross reducing here. 3 will go into 216, what, 72 times? Yes. Going to 21 7 times, going to 62 times. So what is 4 times 72? 288, and then pi is part of the number, s to the 6th is the volume. Does anybody have a question about that? I'm leaving my answer in terms of pi, and that's the way you'll do it from here on, okay? Don't put in 3.14 and all that stuff. Just leave it in terms of pi. It's just approximate. You don't want approximate, you want exact. Now there might be times in geometry he asks you to approximate, and you'll use approximately. But then he'll also say, leave your answer in terms of pi, and that just means leave pi as part of the answer. That's an exact one. Alright. Look now on page 382. 382. A summer camp needs to build a field for a new sport invented by one of its employees. The field needs to be rectangular and to have a length 3 times as long and width twice as long as the existing square field. Use S to represent the sides of the square field. So they're going to take a square field, make it into a rectangular field, and it says that the length needs to be 3 times and the width needs to be 2 times. And where to find the area of the field? Speaking of geometry, how do you find the area of a rectangle? Length times width, right? And so that will be 3s times 2s. What's the area? 6s squared. 6s squared. So we did one of your problems for you there. We did number 65 together. This is your assignment. Go ahead and get started on it now.
Wait, what was it into?
6s squared.